好，我们今天这个 season 就是请到了有从日本过来的讲者，然后跟我们讲解一些关于在 Swift 的这个东西的 tool 上面。然后我们现在欢迎他带给我们这个议题，谢谢。
Hello, ni hao. My name is Yusuke. Thank you for having me at iPlayground. I think so far so good staying in Taipei. I love like Taiwanese food. I haven't tried bubble tea yet, so I think I should try more on the weekend. That's my like to-do list in Taiwan. So today I'm going to talk about making your own tool using SwiftSyntax. And have you ever heard about SwiftSyntax so far? Okay, that's good. So that's why I'm here to give you an overview of SwiftSyntax. So again, my name is Yusuke. I work for Mercari, which provides a marketplace application like eBay, Amazon. And I am a software engineer, and I'm also a tiny contributor of Swift compiler, SwiftSyntax, and also Swift format. All right, so we develop apps, and it could be iOS, macOS, tvOS, or watchOS, or maybe iPad OS. That's really new things, but maybe that's different from iOS. And I think there are mainly two things we often touch. The first one is, of course, source code. We write source code almost every day, and I think this is the most important thing. And also tools, because we use many tools like SwiftLint, Fastlane, or Xcode even, I think it's even a tool. So we cannot do anything without those tools. So that's why I think tools are very important as well. Because tools help make programming easier. So these tools significantly make your source code better. So before we dive into SwiftSyntax, I just want to show you what kind of tools we have using SwiftSyntax, so that you can imagine what we can do with it. First, well, I think everybody knows about SwiftUI, right? So SwiftUI previews. So Xcode 11 provides a preview features for SwiftUI. And this is how it looks like. So left side is source code, and right side is preview feature. So here, if you modify some components here, like any UI label, button, text field, anything, that's reflected in source code, right? And same thing happens in other way around. Like if you modify source code here, that's reflected here. In this part, I don't think it's documented anywhere, but this source code generation is by SwiftSyntax. So SwiftSyntax allows you to have code generation here. Next, Swift format. I don't think many of you heard about Swift's format yet because it's still under discussion, but Swift format will be an official formatter in Swift in the future. And if you're interested about those discussions, please see the link. You can see how discussions is going. For now, you can think of Swift format same as SwiftLint. It's just a lint / formatter tool. So in this example, you have so these two lints or formats into a specific manner of code style. So if you have any like incorrect index positions, it corrects to your specific preference. So that's just a lint/format too. This is also used by SwiftSyntax. All right, next. This is SwiftConst. It's an inspector to finding repeating strings in your project. This is developed by me, and it's still beta version, so I don't think it has many functionalities yet. But probably I will extend these tools to finding like other repeating things like functions, call, or protocol conformance. This is an output on terminal when you run SwiftConst. So like I said, you can find repeating strings in different places. Like for example, this case, row strings error and help are used in different lines, different columns. So that maybe, for some cases, it's better to use constants instead, rather than having same row strings in everywhere. So that's, this is also used by SwiftSyntax. Okay, so, so I believe you already saw the power of SwiftSyntax. And it is a great tool for Swift tools, okay? So before we jump into SwiftSyntax, I think this screen is very familiar with you guys. When you have, crash on Xcode, like this guy say, SourceKit service terminated. Editor functionality temporarily limited. So when you see this error, like everything is gone from Xcode, like color syntax, code completions, right? I don't think we see this error recently because Xcode is getting improved. But when we write like Swift, I don't know, Swift 2 or Swift 3, it's pretty common to see this, right? Well, actually, Swift lint is built by SourceKit. So we can think, well, actually, there are common functionality between SourceKit and also SwiftSyntax. So you might be able to achieve almost same thing by using either of them. However, comparison with SourceKit and SwiftSyntax takes so much time, especially like performance comparison is really difficult. So this is not my scope in this talk. I only cover SwiftSyntax in this talk, okay? So back to SwiftSyntax. So let's take a look at like, what's SwiftSyntax for first. There are more tools using SwiftSyntax, but I think there are mainly two things we can achieve with it. First thing is code modifier, including sometimes it could be code formatter, but sometimes it could be code generator. SwiftSyntax allows you to change or even generate new source code. Okay? Another thing is code analyzer. This could be sometimes code linter or even code inspector. So SwiftSyntax allows you to analyze Swift source code. So these two things are main functionality. All right, so we cover what's for. So let's take a look at what SwiftSyntax is. So SwiftSyntax is a set of Swift bindings for the libSyntax library. And it aims for Swift tools to parse, inspect, generate, and transform Swift code. So, which means, this is too long, so meaning it's just a Swift bindings for libSyntax. And next question is, what's libSyntax then? libSyntax library aims to represent the syntax tree of the source file. So libSyntax creates source tree of Swift source code. I think you already know how syntax tree looks like, but let's take a look at example of really simple example. This is 1 plus 2 in Swift code. And this is, a partial syntax tree of this example. So it has expression list, which has 3 expressions like integer literal expression, binary operator expression, and integer literal expression again. And each expression has, of course, each value. Like if it's integer literal expression, it has integer value here, right? And if it's binary operator expression, it has operator here. So any Swift source code can be represented as syntax tree like this. So it's always a tree structure. And each syntax can have like value itself and also this is called trivia. So trivia is like how many spaces we have, how many lines, how many comment, like what kind of like document comments on the line, so that we can like analyze very deeply with this. Okay. So simplified version of what SwiftSyntax does is SwiftSyntax parses Swift source code into syntax tree. Okay. It's not really difficult, right? So it's just a parsing tool. All right, so let's emit syntax tree. This is for fun. You don't have to do this every time, but let's take a look at like how actual syntax tree looks like. Well, actually, there is an option called emit syntax in Swift command. So if you run Swift dash frontend emit syntax hyphen syntax, and then this parses input file, which is Swift source code, and emit syntax tree as JSON. And here's same example. It's 1 plus 2 in Swift source file, and from the top, so this is the top level of syntax tree source file. And it has code block items, sequence expression, and like same expressions again here. If you're curious about other syntax as well, you can give it a try with different input later. And I like to share a great tool which is called Swift AST Explorer, which is developed by Katsumi here. So most of cases, JSON output is too long to read, right? That's, this is, I think, 20% of output in total. So I just, partially extracted important parts here. But in the end, if you emit syntax tree, it's like this. You cannot read everything. So this tool enables you to show any syntax on web browser. So this is screenshot of that tool. So left side is this is Swift source code, and this is output. So one thing which is really convenient by using this tool is that you can move your cursor on each syntax, and then you can see like any information of the syntax here. So you don't have to read everything. You can just find whatever you want on right side. So that's why this is really convenient. And I think this is a must-have tool when you develop like any tools by using SwiftSyntax or even SourceKit, because we share same syntax information between SourceKit and SwiftSyntax. So I think this is really convenient. So I highly recommend to use it. Okay, so let's recap for now. SwiftSyntax is a parsing tool, and it emits syntax tree. SwiftSyntax allows you to inspect and transform source code. The reason why we need SwiftSyntax is, source file it's like a giant string value for compiler. If you write whatever functions, protocol, enum, variable, but it's just a string value for compiler, right? So if you want to distinguish between whether this is function call or this is protocol conformance, it's quite difficult to detect that because in the end it's just a string value. So that's why we need syntax information to tell you that, hey, this is variable, this is protocol, right? So that's why we need SwiftSyntax. All right, so let's move on how it works. I'm going to share a URL of this slide. So if you feel, this is too details, maybe you can take a look at later. SwiftSyntax is available via SwiftPM. So in package file, you can just specify SwiftSyntax as one dependency. And I highly recommend to specify release tag other than using master branch or development branch, because the only commit with release tag has auto-generated file. So SwiftSyntax uses same mechanism of Swift compiler. They have GYB auto-generated file, which is written in Python. Well, you can think of that like a template language, but they have auto-generated file, and the only the only commit which has auto-generated is release tag. So if you want to use master branch or development branch, you have to manually generate those files. So that's why I recommend to use release tag here. All right, so next, interfaces. I will briefly show you some interfaces. In this talk, it's integer literal case because it's simple, okay? So first, Swift syntax parser. Again, you have to parse Swift source code into syntax tree, right? So syntax parser literally is an interface for that. You can call this parse function with URL of your source file so that you can get source file syntax. You can also pass diagnostic engine as optional, but well, I think you can just ignore that for now. So this is simple. You can just pass URL of source file, and then you can get syntax information. That's it. All right, so let's take a look at what source file syntax is. So this is a structure of source file, and it's also a top level of node in the tree. Well, same example, 1 + 2 in Swift source file, and it's almost like it's really similar as example of we showed. So it has, it has source file syntax. So these syntax are defined in SwiftSyntax, but it looks almost same, like source file syntax, code block items, sequence expressions, and each expressions here. So next, syntax. So as you can see in the example, I think you saw so many syntaxes. So let's dig into integer literal syntax next. This is a struct. And integer detail expression syntax has, well, actually it has more properties, but for now, let's take a look at digits property. So this has digits property, which is token syntax type. And token syntax type has, so this is also a struct, and it has a text property here. And this is a syntax node representing a single token. So each, like whatever expressions, it doesn't matter. All the expression has, it is a token syntax. So meaning you can get any value by accessing this text property to get actual value. So if it's integer detail expression, there must be like integer value like 1 or 10, 20 as string, right? And there are more syntaxes as well, like identifier expression syntax, array expression syntax, dictionary expression syntax. Well, this is just an example, so there are so many syntaxes. But you don't need to remember everything. This is totally depends on like what kind of tool you want to develop. Like if it's SwiftPrint, you might have to deal with everything. But if it's like SwiftConst, a tool I developed is, I just want to find in repeating strings. So that's why I only deal with string. Where is string? Oh, here. String literal expression syntax. So depends on your tools. It's gonna be different. What kind of syntax you want to deal with? So to finding what syntax you have to deal with, you can use Swift command to emit syntax tree at the beginning, or you can use Swift ASD Explorer on your web browser. Okay. So next, SyntaxVisitor. So this provides a way to visit each syntax, which means that, so for integer retail expression syntax case, we can actually visit each integer retail expression in this case. And then like you can check actual integer value in this function, right? And there are two functions, visit function and also visit post function. It's almost same, like these functions, the only difference is that this function can return syntax visitor continue kind, which has only two values for now. Like it's whether visit children or skip children. So you can decide whether you want to like deepen into syntax tree, or you can just say, hey, well, like I found the value what I want, so let's stop like to dig into more deep structure. And visit post is a function which is called after visiting. So you can do the same thing, but the only difference is just whether you can return these values or not. So these are places where you can inspect something, right? So next one is SyntaxRewriter. This provides a way to rewrite each syntax. This also has visit function, and you can return whatever syntax we want. In this case, as integer retail expression syntax. So you can even return existing syntax like this. This is a predefined interface, so you can still use existing syntax, or you can return a little bit modified version of syntax, or you can even create a new syntax. So this is a place where you can transform syntax to any syntax you want. Right? So these two, SyntaxVisitor and SyntaxRewriter, are main interfaces you have to deal with. But basically, that's it. I just want to introduce a convenience interface, which is SyntaxFactory. So this provides so many convenience factory methods to make a syntax. For example, this is make integer literal expression. So this literally makes an integer literal expression. As long as you use this factory method, you don't need to care about like these details. Like you don't need to care about like raw syntax, syntax data. I think this is too detailed. So I recommend to use factory method as much as possible. All right, so we covered what SwiftSyntax is and also how it works. So I have two showcases in this talk that like how we can actually integrate SwiftSyntax into your tool. So first one is odd number inspector. This is a really like super lightweight linter. Well, I don't think this is really productive, so I don't recommend to use this tool in production. So what it does is this tool tells you that like this tool's warrants gives you a warning that hey, you're using odd number for UI code, so please use even number instead. Well, maybe all designer, but some designer might have like preference to use even number for UI code, right? So this is a linter tool for that. To do so, we need to visit integer literal expression, right? So let's see how it works. So first, we define a struct, which is odd number inspector, right? And then this conforms to syntax visitor because we want to visit each integer literal syntax. And then we use visit post function in this case. And then, as you can see in the previous syntax definitions, what we have to do is just one thing. It's really simple. We access to node.digits.text so that you can get string, you can get integer value as string. Okay? And since this is odd number inspector, I checked if it's like even or odd, and then if it's odd, this prints like, hey, let's use even instead, not odd number. So it's not really difficult, right? You can just check actual value by accessing digits.text, and then you can analyze anything you want. And one more thing you have to do is that since this is a command line tool, there's a main file, and you have to parse Swift file to Swift syntax, syntax tree, right? So this is how it works. You can just call, you can just use SyntaxParser.parse function with URL of your source file, so that you can get source file syntax. And then you can just walk them with the visitor you define. In this case, odd number inspector is your visitor. This is pretty much everything. So if you run this tool on your terminal, it prints warning on your console. Not actually this source comment, but you can see that in the terminal. Okay, next one is, well, this is totally like useless tool. This tool multiplies any number by 10. That's it. So this is called 10 multiplication formula. This is also super lightweight formula. So this tool multiplies like any integer value by 10. To do so, we need to rewrite integer literal expression. So let's define a rewriter struct. Sorry, this is a class, and this conforms to SyntaxRewriter. Okay, and I use visit function in this case. Then you can return new integer literal expression for this example. So what we have to do is, it's just multiply integer value by 10. So first thing you have to do is to get integer value as string, which is here, right? Same way by accessing node.digits.text. And we have to make a new syntax of integer literal expression by using convenience factory method here. And you don't need to worry about these trivias for now, but the only thing we have to care about here is that we actually multiply this integer by 10. And then we can get new syntax for integer literal. Okay, and then we can return that as digits so that we can get new integer literal expression syntax. That's it. Same thing again, we have to parse source file, switch source file to syntax tree first, and we can also walk them with the visitor we defined. So it's not really difficult. You have to follow certain things, but it's just a few things you have to do here. And if you run this tool on your terminal, this source code is already modified. So that's how 10 multiplication formatter works. Okay, so these are just example. So you can make more practical or productive tools for your project. Well, it could be internal tools, but it could be public tools. It doesn't matter. These definitely make your source code much better. And well, this is my personal opinions, but well, sometimes tools are better coder than you. Like especially, well, that's why we need SwiftLint, right? I think we are good at business logics, but we don't wanna like look at syntax, like how many syntax we have, how many lines. That's really boring. So that's why we have tools to correct those code style. So sometimes we can let them work for us, or sometimes we can work for ourselves. You can choose. But I think making tool makes your time, makes your source code better. So that's why, well, even not using SwiftSyntax, but any tools would be really beneficial to have in your project. So that's why I want to share like how we can use SwiftSyntax in this talk. Before ending my talk, I like to mention about a few big improvements in SwiftSyntax, because especially last year, like many people said, hey, like SourceKit is much faster than SwiftSyntax, but things changing, so that's why I'd like to introduce some of the improvements. So these first two things actually improving SwiftSyntax a lot. This is like a different approach. So this is too detailed, so if you're not interested about this, we can just ignore this for now. But SwiftSyntax used to use Swift command, emit syntax, in there. So what it does is they call Swift command in SwiftSyntax, and then they can get JSON output, and then they can map that JSON structure into their syntax. So there was an additional layer that, like, they are parsing twice from syntax to from Swift source code to JSON and JSON to syntax, which is not really efficient, right? Now Swift compiler is supposed to have a syntax binary data. So we don't need to parse Swift source to JSON anymore in Swift syntax layer. They can parse Swift syntax to binary data directly. So that's why it gets so much faster. So that's about first thing. And second thing is that if you came to Swift for TensorFlow talk yesterday, I think you saw a pipeline of Swift compiler. And libSyntax is not mandatory pass in Swift compiler, meaning that's only for Swift syntax. So libSyntax is optional in Swift compiler. But that's because Swift compiler is not really designed for libSyntax itself. What it does is Swift compiler parses Swift source file to AST, abstract syntax tree directory. And when we want to use SwiftSyntax, that's the only time when we hook with libSyntax in Swift compiler side. So Swift compiler can choose whether they parse Swift source code to AST or syntax tree. But in other language, I think it's pretty common to have syntax tree first and then abstract syntax tree, right? So that's why we are going to integrate libSyntax into Swift compiler pipeline. So that this is also this gets Swift syntax faster. Last thing, this is quite interesting. If you're familiar with Swift UI, I think you already heard about function builder. So in my example, I think you saw make SyntaxFactory convenience method. But sometimes if you want to create complicated syntax, it's going to be so many lines of syntax creation. And sometimes it's not readable, and sometimes it's just not understandable. So this feature provides a new way to create syntax by function builders. It's almost same interface of Swift UI. So it's going to be more declarative and readable. Right. So Swift is statically typed language. So you should take benefit of the feature. We used to write Objective-C. Well, that's good, but Swift has more benefits than that language. And then we can analyze any syntax information or sometimes type information. Although Swift syntax doesn't support any type inference check yet, but in the future, we might have a new tool to find in those information so that we can analyze very deeply. And useful tools make better apps. So you should let a boring stuff to tools instead of writing any code by yourself. And as I showed you in the previous slide, Swift syntax is improving significantly. So it's going to be faster than before. these are references I mentioned in the slide. So if you're curious about this, please take a look at that. All right, so this is all my presentation. Thank you so much. 谢谢。